right, we're going to skip ahead and go through how to solve a quadratic first before we go through how to graph a quadratic. So that's why we're skipping to 4.3. We'll go back to 4.1, 4.2, but 4.3, solving x squared plus bx plus c equals 0 by factoring. You guys have factored before in Algebra 1, but again, it's something that's really important that you have to be able to do in Algebra 2, so we're going to go through it and make sure we understand it. Just some things you need to know about what's a monomial, what's a binomial, what's a trinomial. When you factor, you're just basically writing a number as two products. I mean, it would be the same thing as if we factor 12 as wrote as 3 times 4. Okay, that's factoring. Okay, so that's what we're doing, is pretty much breaking apart a problem into 2 parts. So right here, factoring. What the method I teach is the X method, which is you want to make an X, and we want the factors of C, which in this case is 20. We want factors of C to add up to B, which is -9. Okay. So what are factors of 20 that add up to -9? Well, that would be -5 and -4. -5 times -4 is positive 20. -5 plus -4 is -9. So you rewrite it as x minus 5, x minus 4. And that would be your answer. Okay, and that's pretty much it. So we always want to find factors of C that add up to B every single time. And write it as a 2 binomials, right? A trinomial as a factor of 2 binomials. Same thing here. We want the factors of C, in this case is -12, to add up to 3. So which 2 numbers multiply to get -12 and add to get 3? Well, are there any? Let's see here. There's 6 and 2. Is there any way that 6 and 2 can make 3? No. There's 4 and 3. Is there any way that 4 and 3 can make 3? No. There's 12 and 1. So this one I think is unfactorable. 6 times 2 is 12 and -12. 4 and 3, 12 and 1. Yeah. There's nothing that's going to multiply to get -12 that's going to add up to get 3. Okay. So this one would be, you'd write not factorable. And that's all you have to write. If it's not factorable, just write that and you are done. Okay, these you can practice on your own. We'll practice those in class, or you can work them on your own, on your notes. But we'll move on to the next one, okay? Special products. Special products are really important. Factoring quadratic expressions often involves trial and error. However, some expressions are easy factors because they follow special patterns, okay? So you need to know these. These are really important. You need to know both of these. And I've done a bad job in the past of teaching this one, perfect square trinomials. But it really helps you. If you can understand perfect square trinomials, it'll help you when you have to learn other ways to solve later, like completing the square and other methods. But we'll go through this, but the main thing you want to notice about when you do special factoring pattern is you basically just want to look at the first and last term. And most of the time, the first and last term, to try and keep it as simple as possible, leads you to a perfect square trinomial. All you have to do is take the square root of those 2 terms and write them as a binomial squared when you have a perfect square trinomial. So if the square root of x squared is x, the square root of 9 is 3, then the how to write that in factor form is x plus 3 squared. Same thing here. The square root of x squared is x. The square root of 4 is 2. So it would be x minus 2 squared. The thing you have to pay attention to is this minus sign. If it's a minus in the middle, then you put a minus there. If it's a plus in the middle, you put a plus there. Okay. So I have to do a better job of teaching perfect square trinomials. Now, the difference of 2 squares is a little bit different, but it's easy to see because there's only 2 of them. On every other time, it's a trinomial. This one's a binomial. Okay, there's only 2 terms. So if you have a perfect square minus a perfect square, then it always will factor into the difference of 2 squares. So you take the square roots and you add and subtract them. So the square root of x squared is x. The square root of 4 is 2. So you end up with x plus 2, x minus 2. The difference of two squares, again, you only have two of them. That's how you'll be able to tell if you can do that. There's a factoring flow chart in the back of my room where you can look and see two terms. You should be thinking difference of squares or some other method. Okay. So let's talk about these. X squared minus 4, only two terms. So it's probably difference of two squares. So what you want to do is find the square root of each of those. What's the square root of x squared? X. What's the square root of 49? 7. So then you do the difference of two squares. You do x plus 7, x minus 7 is how you factor that. And you can check that by factoring, because when you factor, or when you FOIL it, when you FOIL it, the middle term should cancel out. Same thing on the other one. Okay, this one has three terms, so it's a perfect square trinomial. If you look at the first term and the last term. Again, you should pay attention to the middle term too, but I'm trying to keep it as simple as possible. But if you look at the first term and last term, they're both perfect squares. You should be able to take the square root. So square root of d squared would be d. The square root of 36 would be 6. The middle term is a plus. You can keep it as a plus. It would be d plus 6 squared. And that's how you'd write that as a perfect square trinomial. Last one, three terms. We're talking about z squared. Is that a perfect square? Yes. What's the square root of z squared? Z. Okay. And it's 169 a perfect square. Yes. What's the square root of 169? 13. But there's a minus in the middle. So since there's a minus in the middle, it has to be z minus 13 squared. And that's how you factor special patterns. If you can pick those shortcuts up to be able to recognize perfect squares, and this is where it's important to maybe make a perfect square list, like 1, 4, 9, 16, 25, and keep going. You know how to make a perfect square list. Is 1 times 1 is 1, 2 times 2 is 4, and so on. Then you'll be able to pick those out and know your perfect squares. But you have to know your perfect squares to be able to do this. If you don't know your perfect squares, you can't do this one. So that's something you have to study. Ladies, again, we'll work on these in class just so you get practice. These are all perfect square trinomials that you get work with. Okay, solving quadratic equations. You can factor and solve certain quadratic equations. The quadratic equation is one variable can be written in the form ax squared plus bx plus c, where a does not equal 0. This is called standard form of the equation. The solutions of the quadratic equation are called roots of the equation. The left side of ax squared plus bx equals c can be factored, then the equation can be solved using the zero product property. And the zero product property just basically means this. You can set your quadratic equal to 0, you can factor it, and if x plus 5 times x plus 2 equals 0, then x plus 5 equals 0, or x plus 2 equals 0. So once you factor it, that means the answer is the opposite. Because if you solve x plus 5 equals 0, you're going to get negative 5. And if you solve x plus 2 equals 0, you're going to get negative 2. So once you get in factored form, it's pretty much the opposite of what you get as, or the sign of what's in the factored form. And all you have to do is set equal to 0 and solve. So on this one, when they give you x squared minus 5x minus 30 equals 0, they say to factor and solve, what you have to do is, this is trinomial. Now, this one is where it gets a little hairy because I said just look at the perfect squares. Both of those are perfect squares, but this middle term does not represent one that's perfect square. Okay, so we have to do our x mark. So we got to make our x factors to negative 36 and add to negative 5. What two numbers multiply to negative 36 and add to negative 5? That would be negative 9 and 4. Negative 9 times 4 is negative 36. Negative 9 plus 4 is negative 5. So then you rewrite it as x minus 9, x plus 4 equals 0. Then you would set both of those factors equal to 0. So you set x minus 9 equals 0, or x plus 4 equals 0, and you solve them both. You get 9 or negative 4. So 9 or negative 4, which would be C. Now, once you get good at this, again, at practice, you'll start to realize that, oh, it's x minus 9, and the answer is going to be 9. if it's set equal to 0. If it's x plus 4, the answer is going to be negative 4 when it's set equal to 0. You don't even have to do all that work on that last part. But until then, write it out as each part equal to 0 and solve it. Okay, the town has a nature preserve with a rectangular field that measures 600 meters by 400 meters. The town wants to double the area of the field by adding land as shown. Find the new dimensions of the field. So if we want to double the area of the field, we got to find the original area of the field. We'll find the original area by doing length times width. So length times width in this case would be 600 times 400, which equals 24 with 4 zeros. That is the original area of the field. If we want to double the area, then double that would be 480,000. So we got 480,000 equals, and now we have to add in those x's. So instead of just 400, it's going to be 400 plus x times 600 plus x. Because 400 plus x would be this length right here, and 600 plus x would be this length right here. And we measure area by length by width. So if we want to double it, you're adding x to each area to get double the area. And we know double the area, since the original area is 240,000, would be 480,000. So now we're going to FOIL. So we have 400 times 600, which is 24 with 4 zeros. We got 400x and 600x. Get rid of that. Which would be, you have 400x plus 600x. You FOIL, you get 1000x. And then we have x squared. So I'm going to rewrite this a little bit just to make it easier. We have x squared plus 1000x plus 240,000 equals 480,000. So then, on all these, we always need to set equal to 0. So to set equal to 0, we subtract 480,000. And we get x squared plus 1000x minus 240,000 equals 0. Now we need to do is find out what factors of negative 240,000 add up to 1,000. This is a little bit more difficult than some of ours have been dealing with. But if you think about it this way, if you think about a positive, well, the answer is kind of hard to think about. But if we think about two numbers that multiply or that add up to 1,000, that could multiply to 2,400. The numbers that popped in my head are 1,200 and negative 200. Because 1,200 minus 200 would be 1,000, and 1,200 times negative 200 would be negative 240,000. That might be hard for you to figure out, and we'll try and practice on some of the bigger numbers we have to do that. You won't have to use bigger numbers most of the time, but sometimes you need to figure out the bigger numbers and how to factor. But those do work if you add those together. So we would rewrite this factored as x plus 1,200, x minus 200 equals 0. So what are the two answers for that? Well, this answer would be negative 1,200, which can you have negative 1,200 as your x? No, because you can't add negative 1,200 to 600 and get a positive width of your field. You can't have negative numbers in real world problems with area. So we know that's not going to be right. So x minus 200, what would be the answer? Would be 200. Which, if we double check that, if we put 200 at the top of the part and find out, I don't know what that was. Put 200 right here, and we put 200 right here. 200 plus 400 would be 600. By 600 plus 200 would be 800. And 600 by 800 would be 480,000, which is what we wanted in the first place, so it does check out. So it says, find the new dimensions of the field. The new dimensions would be 600 meters by 800 meters. 600 meters by 800 meters. And that would be the answer to your problem. Okay, so that one's a little bit difficult how to set up, but that's how you go about setting it up. We'll practice some of those in class, and we'll practice that on guided practice number 9 if you need help. So do 8 and 9 on your own. Zeros. If they say find zeros of the function, and we haven't talked about 4.2 yet, but zeros and roots all mean x-intercepts. They all mean the same thing. So if they say find the zeros of the function, all you have to do is plug in 0 for y and solve it the same way you have it solved. So if it says find the zeros of the function by rewriting intercept form, plug a 0 in for y. So it would be x squared minus x minus 12. You want to factor it. So factor is negative 12 adds negative 1, which would be negative 4 and 3. Negative 4 plus 3 is negative 1. Negative 4 times 3 is negative 12. So you rewrite it as 0 equals x minus 4, x plus 3. And your two answers would be 4 and negative 3. And those would be the zeros of that function. Let's go to the next one. We want to find the zeros of y equals x squared plus 12x plus 36. Again, zeros just mean the roots or x-intercepts. They're all pretty synonymous. They all mean the same thing. So if they give you y equals and say find the zeros, you plug in 0 for y and solve it. So, got to find factors of 36, add up to 12. Again, this one actually is a perfect square trinomial. The reason I know it's a perfect square trinomial is because these two numbers are the same. 6 times 6 is 36, 6 plus 6 is 12. So I could rewrite this as 0 equals x plus 6 squared, or I could rewrite it as 0 equals x plus 6, x plus 6. But if I get the same thing twice, it's a perfect square trinomial. But my only 0 in this case, it doesn't matter, is my 0 would be x equals negative 6. That is the only 0 on a perfect square trinomial. We'll practice those in class, and that's your homework, and we'll talk about that when we get past the guided practice. So if you have any questions, ask me in class, and that is it.